All right, chapter 14, sampling. This is from Rubin and Babby. Research Methods for Social Workers, 7th edition. In today's podcast, we're going to give you an overview of research sampling for social work. We'll take a look at non-probability sampling, the process of selecting informants in qualitative research, talk a bit about sampling, probability sampling, discuss sampling biases, and solutions to minimize problems with sampling. When we talk about research sampling, we have two broad types, probability sampling and non-probability sampling. Both of these sampling techniques have the same thing in mind, to select a subset of a population for the purpose of making inferences about that total population. There are times when probability sampling is not the best or the most appropriate technique to use. I say this despite the fact that probability sampling techniques, the random sample, are the highest standards by which quantitative research can obtain its research participants. Then why do we use non-random samples or non-probability samples? Well, we do that because oftentimes we are on a budget that does not allow us to conduct a random sample. Then other times we are doing a qualitative investigation that requires us to purposely select the participants to include. Each in turn, I will talk about the four basic types of non-probability sampling: reliance on available subjects, purposeful or judgmental sampling, quota sampling, and finally snowball sampling. Reliance on available subjects is often called convenience sample. So for example, if I wanted to do a survey of the social work program or of students at UMKC, I could just hand out surveys to you all in class, or even have you do it through Blackboard, in which case it would be called a convenience sample. Now, for example, if I wanted to do a purposive or judgmental sampling technique, I would use that whenever I wanted to ensure that I had the exact type of participant that I wanted. I would do something like limit my sampling only to that subset of the population that had the criteria that I was looking for. For example, say I wanted to know about the first impressions of graduate students with online education. What I would do is approach all graduate programs in the university and ask them to administer my survey to their newly admitted students in their graduate programs who are also taking online courses. In the example of the research class, that would mean that the Tuesday class would not be approached and the Thursday class would. Sometimes we want to ensure that our sample contains adequate representations of a desired subpopulation, and in that case we would use quota sampling. Quota sampling will make sure that we have a relative proportion of the total population within our survey. So for example, if we're doing a study of Kansas City and we want a quota sample, our sample should contain the same percentage of whites, blacks, males, females, Hispanics, Native Americans, etc., that the general Kansas City population has. Finally, when we have a very specific and hard to recruit population, such as homeless peoples or members of some ethnic subgroup, we use a process called snowball sampling to accomplish our recruitment. When I conducted my study of the Native American Church, I relied on snowball samples to find appropriate people. The Native American Church, unlike some other churches, does not maintain or make available its membership rolls. In addition to lacking membership rolls, I was looking for a specific subset of Native American church member, the person who had used the religious organization to support their abstinence from alcohol and drugs. A very specialized population indeed. The easiest way to find new recruits was to ask people whom I had interviewed to make referrals. This serves not only the purpose of finding someone to interview, but because you had a member of the community recommend you, it gave you some legitimacy to the new prospect, thereby making the research process just a little bit easier. And with research, any little bit easier is good. When we think about participants in qualitative research, we will often use the term informants. Again, here's a word that has multiple meanings and is often referred to as somebody who gives information to the police department. Therefore, depending on your research population, they could mistakenly think that you were referring to them as snitches or narcs, or etc. The various negative names that are developed for people who inform on other people. When we recruit participants into qualitative research, we do so because we believe that they are qualified or knowledgeable and are willing to share that knowledge with us. Usually we pick someone who has intimate knowledge of the phenomenon or of the group we are studying. Therefore, if we are studying inmate behavior, for example, we could potentially interview inmates, prison guards, intimate partners of inmates, etc. Since we often don't have the luxury of doing a random sample in qualitative research, it is important to then purposely make sure that we get the kind of sample we want. If we want a typical example, we should endeavor to define what typical means before we start our research. And, of course, it might not hurt to ask informants themselves, do you consider yourself a typical example of fill in the blank? Probability sampling is used primarily only for quantitative studies. The chief reason we pursue probability sampling is that we desire to obtain a sample that is sufficiently similar to the entire population that we can generalize our findings to that entire population. The fundamental principle of probability sampling is that no one individual is more likely than any other individual to be selected for participation. There are a number of techniques, which I will explore in just a moment, to obtain a probability sample, but each of those techniques is only as good as the laws of probability itself. Even the most carefully selected sample will almost never perfectly mirror the qualities of the general population. There will always be some degree of sampling error, and there are mechanisms that statisticians and researchers use to estimate the degree of that error. However, some of those techniques are a little bit more advanced than an introductory research course would require. Before we dive in how to do probability sampling, we should probably define a few terms. Rubin and Babbage refer to the element, and that is the term that in other contexts might be called the unit of study. It is the most basic unit about which information is collected and then provides the basis for analysis. In fact, sometimes it is called the unit of analysis. Population is a theoretical concept for each study. If we were studying United States citizens, we would probably theorize and conceptualize our population based on the way the U.S. Census Bureau has conceived it. Oftentimes, however, we work with much smaller populations. For example, we want to study mental health consumers in the Kansas City metropolitan area. There are quite a number of people with mental health concerns, and there are many locations from which we can find them. So, for example, if we sample from a Swope Park mental health clinic and a Johnson County mental health clinic, we would say that those two clinics are our study population. The ultimate purpose of probability sampling is to select a set of elements or individuals from a population in such a way that the description of that subsample of individual accurately portrays the total population. The primary tool we use to assure a good probability sample is the use of random selection. In order to randomly select, we first need to create a sample frame or sampling frame. In the case of mental health consumers in Kansas City, we selected Swope Park and Johnson County as our study population from which we will draw the random sample. In order to do that, we must get a list of mental health consumers from those clinics. And if, for example, we were only interested in people with schizophrenia, then we would add to our list from Swope Park and Johnson County Mental Health of their consumers with schizophrenia. Then we would set about the task of random selection. Example populations can be of almost any variety. School children, high school students, members of bowling leagues, retired people, etc. The research process is one of never-ending attention to concern that bias will produce false results. In addition, we are concerned with bias when we engage in the sampling process equally as any other phase. We do this in order that our results are not overgeneralized to the larger population. This overgeneralization happens when we do not successfully produce a pool of informants or participants that shares equally the characteristics of the entire population. There are times when we can set up a nice-looking sampling frame only to have our results be biased because of some individuals not responding. Sometimes the non-response rate is not problematic. For example, when it is very small, or when it distributes equally across the entire population. However, we often do not know how it distributes because we do not know the important elements of those who do not respond. Non-response is often a problem of other parts of the research design. We make long and confusing surveys so people do not bother to complete the survey. Other times our instructions are not clear and they do not submit the information properly. And there are numerous other reasons as well. So even when we go to the effort of making a wonderfully culturally competent survey instrument, we can still create cultural bias when we fail to properly sample. This is particularly problematic when we have small surveys and small subpopulations. For example, we tend to concern ourselves with research instruments being valid at about a 95% rate. We will go into that a lot more deeply in the next semester. However, for now, just know that we only allow about a 5 out of 100 error rate. So if you're researching the entire population and an important dynamic of your research is race, then be aware that any population that has a small percentage of the whole becomes quite easily to get a misrepresentative sample. For example, Native Americans comprise between 4 and 5% of the general U.S. population. So, if we are on a limited budget and draw a sample of 100 people, we would get between probably 1 and 8 Native Americans in that sample. First of all, if you are doing any kind of statistical analysis, just having 8 people is very problematic. Even if you have 92 other people, we have to consider each subpopulation independently. However, if you only have 1 in your sample, then it becomes impossible and ethically wrong to generalize your result from that 1 person to the entire population. So even though you may have a research instrument that is very competent culturally for Native Americans, The failure to adequately choose enough Native Americans to adequately analyze would make your overall research culturally biased. Gender bias can also happen in a similar way. Although, because there is roughly a 49 to 51% ratio of males to females, it is much easier to get adequate numbers of each gender. However, if you were studying social workers or social work students, it might be difficult with simple random selection to get enough of social workers to adequately portray their worldview. Get enough male social workers to adequately portray their worldview. Pause. Now, when we think about probability sampling designs, we're thinking about basically three designs or some subset of those. There's the simple random sampling, a systematic sample, and a stratified sample. The process of producing a simple random sample is, in a word, simple. Once you have obtained your sampling frame, then it is possible to assign each element of that sampling frame a unique number. Rather than using a unique number, such as Social Security number, it is best to simply assign them. We do that because sometimes when you utilize numbers provided by the respondents, you may get two of the same number. Even with something like Social Security number, a clerical error could result in problems. Next, you may either use a table of random numbers, such as found in the back of the appendix in Rubin and Babby's textbook or any other statistic book, or you can use software such as Excel, SPSS, or the R statistical program to generate a random selection for you. Again, this is something we all have the opportunity to do in the coming semester. Systematic random sampling is a spin on simple random sampling in that it uses an interval to select, quote, at random. Systematic random sampling requires that you set up your data in a random way. It is important that you do not have any clustering subgroup. So, for example, if you were to systematically randomly sample people in the School of Social Work, staff, faculty, and students, and your sampling frame was organized in that order, it is very likely that you're going to get few or no staff, very few faculty or just one, and the rest students. So it's important to carefully examine the nature of the list and whether the particular order of the element will bias the sample that you've selected. Therefore, the better way is to use some sort of stratified sampling design. In the previous example, we would separate our pool into staff, faculty, and students, and then randomly select from each pool. In reality, since we only have one staff at this point, we would probably just include that one person or lump them in with the faculty group and call it school employees. Stratified random sampling is a good way to reduce sampling bias when you have subgroups that have dramatically different concentrations within the population. Multistage clustering sampling is a much more complex technique. Using any type of cluster sampling, we will first randomly select from within a cluster, say everyone in zip code 64109. Or we may randomly select just blocks from 64109 and then randomly select with each one of those blocks. Or we may be a little bit more purposeful. We would randomly select blocks for efficiency purposes. For example, if we were going to do door-to-door surveys, it is much more practical to work in some sort of a block or neighborhood format versus driving all over the city, which is why you'll often see that certain counties are selected to test new programs, or only certain states participate in demonstration projects. So, probability sampling can be very simple when you're working from a simple data frame, and when your research question does not require careful attention to the inclusion of subpopulations. However, whenever possible, and always when your research question demands it, use some sort of mechanism to ensure racial and ethnic minorities are adequately and proportionally included in your selections. End of it.